In this tutorial, we will be looking at some advanced methods of analysis. To view spectral content for the selected period, you can calculate a fast Fourier transform by clicking on FFT. The time to calculate the FFT increases significantly with longer selection periods. This is because the FFT is calculated from the full resolution measurement files. The FFT function should generally be used for selections of less than 1 minute. A warning will display for selections longer than 1 minute. Power spectral density curves are shown along with a visual representation of the sample distribution. The spectral plot is initially displayed with frequency in a linear scale. This can be changed to logarithmic scale by clicking the log frequency checkbox. Increasing the overlap and window length increases resolution, but also the processing time required. Various time window types can be selected from the drop-down menus. The default Blackman-Harris is a good general-purpose window and suitable for most applications. Other window types may be suitable depending on the frequency content of the signal. The power spectral density curves can be viewed for each hydrophone by selecting from the drop-down menu. The spectrogram button enables visualization of the FFT varying with time. Click on Signal to display the high-resolution signal of the full-resolution measurement files. As with the FFT analysis feature, signal analysis should only be used for short time period selections of less than a minute. The 4 radio buttons above the signal plot enable the user to select the type of display. The waveform shows the raw signal of the measurement file. The signal is limited to plus or minus 1, which is the maximum range of the signal. This is useful for identifying overloads and signal clipping. SEL displays the accumulated sound exposure level in dB. SPL displays instantaneous sound pressure level in dB. Energy displays the accumulated energy, or exposure, as a percentage of the total selected signal. This is useful for finding pulse durations and rise times of individual pulses. The tables on the right display the calculated rise times and durations of the selected signal. Click on Bands to enable visualization of the 1/3 octave bands, weighted to reflect the setting selected on the home screen, as well as a visual representation of the sample distribution. This performs a similar function to the FFT, but it is significantly faster. This is because the spectrogram displays the data already stored in the LVX files. This enables the bands function to summarize data from a selected period of data in real time. Probability density curves can be viewed by click on the View Frequency Statistics checkbox. Exposure enables evaluation of cumulative exposure over the selected period. It also presents time stamps for the 90% energy interval, that is, between 5% and 95%, and marine weightings can be applied to enable direct comparison with relevant cumulative exposure criteria. It is particularly useful for evaluating cumulative exposure from activities such as multiple strikes during pile driving. Watch Tutorial 5 next to learn how to use tags.